Okay, everyone. My name is Mobile Broman. I'm here today just to talk about our CMS for Inventor solution. So I really appreciate your time that you are joining us this afternoon. If you're in the in the uh, from Europe somewhere, or and also somewhere from Asia, and if you're on the East Coast, still afternoon. But if you're on the West Coast, I guess still good morning, I believe. Okay, so we're going to be talking about our CMS for Inventor, as I said. So we're going to just try to give you a quick rundown here what the software actually does, and talk a bit about how we can quickly achieve um, to create NC1 file directly from your Inventor models, right? So as we already know from this webinar that we are trying to convert our Inventor models to NC1 file, and as we probably know by now that the DSTV is the German standard and just a standard, right? The extension file that we create from our software is .nc1. So you're going to see that some of the people will call it DSTV file, some will call it NC1 file, but at the end of the day, it's just the same file, just a different naming, right? What we are trying to achieve through our solution is how we can quickly achieve within few clicks convert your native models to NC1 files. It could be your part files, it could be your assemblies, both it could be your profiles, your plates and sheet metals. We're going to be covering all those cases today. One of the things that we really want to mention that we can cover almost any kind of libraries, ship libraries that we have. Whether it's an AEC standard, imperial standards or metric standards. On top of that, if you have your custom library, even we can work on those. That means if you have your custom shape sizes, not the custom profile type, right? So the regular profile types, your channels, your beams, your tubes, rectangular tubes, your square tubes, for example. But if you have them on different sizes, we can work on them. In terms of machine types, any machine that runs on DST files will be able to support them. But these are the some examples over here that we have listed. Those are the major players that we have been working with. Voortman, Peddinhaus machines, Ocean Machinery machines, PythonX, very popular. Prodevco, Ficep, and Dimcut. That's a Canadian company here in Prodevco as well. And also from Europe, AGG, or RoboRail. So, any of the machines that you have and you want to fed NC file from your Inventor model, then this is where we're going to come in and help you create, just bridge the gap between your machinery and your Inventor platform, right? So just a quick advantage on in the software, there is no system requirement, just the software is a plugin, right? So no additional requirement as long as your machine can support Inventor, that can easily support our CMS for sure, right? In terms of user control, when it comes to your user control on the Inventor, so there's nothing much changes when you install CMS. So the only thing that you have to make sure that your users have access to the shape library that comes with our software. Okay, so the software actually installed the shape library on a specific path. So if the user doesn't have access to that path, your IT might have to go and get in and help that to put those two shapes libraries there. Again, it's very straightforward stuff. It's nothing big deal. In terms of licensing, we are totally on web-based licensing system, just like your Inventor platform. So you don't have to have any server if you want to use a floating license, right? So let's say you want to use one license within your team, then we can definitely support that, right? Just a quick understanding what kind of users so far that using our software. Definitely well, we are not a primary steel structure solution, right? I know that's very obvious. Most of the people will be doing in probably in Tekla or SDS2, those kind of stuff. But when it comes to secondary steel structures, in the mezzanine, your fault protection systems, staircases, those are the ones that you create an Inventor, right? And then we can quickly convert those to NC1 file, right? We have been working with transmission and distribution tower manufacturers, and also including equipment manufacturers. As you see on this over here, there's few of our for clientele here that and that we have been working for a couple of years now. So bottom line is, if you have any models that has been done on Inventor, in structural structure and even miscellaneous still, we can convert those files to NC1, regardless whether you have it on an Inventor, I mean in IPD format, or in a step file. Your client is sending you in as a step file. As long as you can open that step file with your Inventor platform, for example, we'll be able to help you on that, right? Just to quickly let you know, we have other solutions as well. We run on SolidWorks as well in AutoCAD, and at the same time we have a DXF reader. So if you have any DXF, 2D DXFs, and you want to convert to NC file, we have that solutions on hand as well. But today we'll be talking about CMS for Inventor. So before we start talking about that, just wanted to give you a quick idea what the DSTV file is for the fellow who are actually new in this area, right? Again, as I mentioned on my very beginning, in my second slide, just a standard that we follow, all over the world when it comes to DSTV, that's been adopted from German standard. So just a text file, any NC file that you can open with your Notepad, for example, as you see on my left side of the screen, and that I have given an example here. So any files that you open with Notepad, you're going to see that NC file is starting with an ST command and ending with an EN command, right? So within the few lines that you're going to see, there's some header lines, so we call them header data, right? So when it comes to Inventor, within this few lines over here, so on top of those lines here, so in total of 5 lines. So what we do, we can map those lines depending on your need, depending on your supplier's need. Or if you're doing manufacturing, fabricating on your own premises, depending on your need, we can always map those one from your iProperties as well. And definitely your NC file will be describing your operations, right? So if you see anything on a block as an AK, so that means talking about your external boundary, right? And if you see any additional details on those lines over here, what's talking about is actually talking about bevel descriptions as well. So our software can grab your any details in terms of any kind of cut. So if it's scopes, miter, and if you have any kind of bevels also on the boundary, on those external contours, right? We'll be able to capture them directly from your Inventor model, right? Additionally, if you have anything, cutouts, internal cutouts, if you want to bring your let's say slots as an IK block, for example, then we can also do that. Holes, hole-wise, slot holes, even special kind of drill types. Let's say, for example, your threaded hole, tapped hole, countersunk and counterbore holes. We can also read them directly from your model, right? The software is also capable of reading your etching content. So let's say if you have sketches on your model and you want to bring those sketches as scribing lines, for example, we can do that as well. Additionally, the software can read emboss feature. If you want to put something, a marking line, for example. Not a marking line is actually a text, for example, as you see on this example, SI is referring to stamping or etching those letters as well, right? So I can read a given emboss feature, or the software has the capacity to stamp that part number. So let's say I read your part number from your iProperties, I can actually put that details on a defined default. So you can tell the software where to put in what phase and where do you want to place it, right? So we can support that operation as well. Last but not the least, is bending. So if you work with sheet metals, we have a very straightforward solution, and we can create that KA block directly from your Inventor sheet metals, and just in one single click, right? So again, just to sum up, just a text file you can open with your Notepad. It has a bunch of operations, and some header lines, and from within those header lines, 5 of those we will be mapping from iProperties depending on your need. Again, or it could be your estimating software or your inventory software has some specific needs on those lines, and could be also needs on your CNC machines itself or your plasma machines itself as well, right? But what we do is actually we can cover more details. We do cover those on more details when you come with us and start to use the software. So we offer a 2 hours training, so that covers also like if you want to understand the DST file in depth, we help you with that as well. So now our main target is how we can automate our thing. How we can, we want to batch process our parts from an assembly. That's your target. That's the reason why you are here, right? So 3 easy steps, and then from there we can create our parts our NC files very fairly quickly. The first thing is the set orientation. So what I meant by set orientation is where is your profile plane is located. So I'm going to be talking about this on my coming slides as well. And the next thing is the shape size. So we need to know that what's the shape size that you're working with. So if you just take a look in the screenshot, as you already know that this is a bill of materials been pulled up in Inventor platform, right? So I know as long as I have those shape sizes in one of my iProperties, and those shape size could be on stock number, it could be on your descriptions, depending on how you model that. On your design process, it could be anywhere when we can map it from there as well, right? And the last thing is the part number. The reason why we suggest to keep your part number is because the part number is a unique number, right, for each and every part. And what we do, we suggest that, and we recommend that honestly, that to save your NC file as your part number, right? So this way we know how many parts we are creating from an assembly exactly. Additionally, just to let you know, the software has the capacity to grab the quantity as well directly, right? So when you have an active bill of materials, you have your part number, you have your stock number, right? And also it lists also quantity as well, right? The software has the capacity to grab all those details directly from your bill of material there. So you don't have to do anything manually, right? So let's just talk about the set orientation thing that we mentioned, right? So as I said, it's the set orientation is actually more about your profile / your sketch plane positioning in the XY plane. So when I say XY plane, I'm just going to show you some examples on the Inventor platform as well, just to clarify that quickly as well. Again, we are talking about automation from an assembly. This is not a requirement for a part level. So anything that I want to see that on an XY plane, so I would say this is my horizontal is my X plane and vertical is my Y plane, my Y axis, right? So that's my XY plane. So anything that I want to create for my channel, I want to see that my profile plane or sketch been placed on that XY plane like you see right there, right? If I've been placed something like that, otherwise I can still work on it, but I will not be able to process it from an assembly level. This is a must. This is a requirement for an assembly process, right? If I'm working on a tube, if it's a rectangular tube, we want to see that long hand standing on this Y side, on the vertical side, right? The same goes for the unequal angle as well. If you're working with unequal angle, this is how we want to see that. The most fun part is if you're using Content Center, or even if you don't touch anything on the profile plane level on the Inventor, by default all those profiles have been placed like this in Inventor like that, right? And that makes our life much easier and your life much easier to process all those members directly from the Inventor assemblies and create NC files in one shot, right? So as I said, that's we call it COLI approach, COLI. So just remember that term. So as long as they've been placed like this on an XY plane, we will be able to process pretty fast. So I'm just going to jump in quickly on Inventor platform. Just want to show those planes there. So this is a channel over here, as you see over here, all right? And if you just take a look on the XY plane, regardless of my face over here, as you see it's on the left face, and I see that my channel plane is on the XY, right? Exactly, right? And if I just go to its eye properties, I just want to show you that this is an imperial shape, right? So I'm just going to move on to my next example here. This is a tube here. As you see, this again on XY. And if I just take a look on my eye properties here, and this is an imperial shape as well, right? And that's, it's on front face, but it's on the XY plane as well, right? So the bottom line is, in order to create my NC file very quickly, I want to see all those on a single plane, right? And then for an I-beam as well. So this is what I meant by orientation of the sketch plane. Okay. So before I move into my other slides, I want to talk about this. I want to start with the part level first, and then move on to a couple of examples that I will show you in different standards, different library standards, and at the same time also, if you have a different way of naming your parts. I'm talking about the shape sizes. Okay, so let's just start with this one. There's a purpose for this one. I use a lot this example over here, just to show you the capacity of the software. Okay, so I'm just going to work on a part level first. Again, as I said, our main goal is to work on an assembly level in order to process, the entire assembly with few clicks and create NC1 file in one shot. But one of the things that you really have to understand, even though if you work on an assembly level, at the end of the day, the CMS, the software, goes to the part level and read the part from the part, right? From the part level IPD files, and then create an NC1 file from there. So this is it's a requirement that we understand how things are being done on the part level, right? So let's just take a look on this part here, right? So that's a very straightforward, that's an frame that's been created from frame generator, as you see here. And even from content, if you bring anything from content center, they will be by default on the XY plane, and that's exactly what we want, right? So if you just take a look in this part over here, I see that if I just zoom in here, I see that I have a cope here, and I have a bunch of drills there, and at the same time I have some slots, right? And we have put on purpose some of the additional features over there. So if you just go in on this design tree there, I see that I have an embossing feature. Just to show you that the software has the capacity to read the embossing feature as well. And at the same time, what I did here is I put an etching line here, right? So let's, for example, if you want to bring that etching line to your NC file, you have to really let the software know which one you want to bring as an etching line. So, you might have hundreds of unused sketches, right? Like any sketch line that not been consumed by the feature, we will be able to grab it depending on your, settings. As you see, what I'm doing here is I'm highlighting that sketch line, and I'm just formatting that one, right? The similar thing is the condition is for the pop merge as well. So if you want to bring anything as a pop merge, you highlight the sketch and just let the software know you want to bring that as a pop mark, right? Now the next thing is is we need to do some quick settings, right? There's some one-time settings that we have to do, whether you work on a part level or an assembly level, right? So the first thing is what I'm doing is I am saving my part name with my part number. So what I'm doing is the software is getting your I properties, getting that part number from there, and it's gonna get there, save it as a part number.nc1. So if you have a different way of doing stuff, you want to do that, still do that. You want to do with the document name over there. If you have an assembly and you want to bring the occurrence names as well, let's say you had, multiple component occurrences, right? But you want to capture all those NC files separately, which is not relevant, honestly, but we had one client was asking for that, so that's why we include that one. And at the same time, it's dynamic naming as well. So what we does is actually it actually can get, if you go to your property links, and you're gonna see that on this Inventor iProperty tab, it's actually listing all of your iProperties that you have access to. We have access to that on that part, right? So it lists everything over here. So anything that I want to include for the dynamic naming, I can just drag and drop it. So as you see, for an example over here, what I did is I just grabbed my part number, for example, right? As you see, okay, you know what? Let me just clear this up quickly, right? I can just grab my part number, for example, and I can just add additional characters in between. So I'm just going to press an underscore, right? And let's say you want what? I want the revision number as well, right? You can go ahead and do that, right? So if you want to add more features, including a custom properties, you can go ahead and do that. So that's how we can name in 4 different ways. We're gonna stick to the part number because we're gonna be focusing mainly on processing on assemblies, and as we said, sticking to the part number would be the best way to move forward to process your assemblies, because part numbers are the unique numbers, and we're gonna make sure that's when we create NC files, we make sure that all those NC files are unique, right? So moving on. The session is, depending on what kind of standards that you use. As I said, the software comes with all standard, including DIN, AISC, and Australia. And we can add more, honestly. As I said, if you have your custom library itself, we do have clients who have their own custom library, and my clients, Masaba Inc., they have their own library, so they will be using. You can name your library here as well, right? So what's happening here is, once you install the software, I'm just gonna kind of drag some file explorer over here, and just want to show you this over here. So what's happened is, once you install the software will be coming with two library here. So the first one is CMS standard shape catalog.csv. So anything that you see over here, this is what we have on that catalog there. So I have other examples over here as well, as you see, just to show you for in future assemblies, I'm going to show you, if you have a different custom assembly type, you can still work on it, right? Well, just wanted to show, the software comes with a library, and all you have to do is, depending on your area, your preference and the type of the profile that you work with. So if you work with metric shapes, so you're going to be using metric libraries, and if you work with imperial shapes, then you stick to imperial libraries, right? So the proper links, again, remember that we mentioned about, on the DSTV files, that some of the header lines can be mapped from iProperties depending on your need, right? So again, those are the lines over here. Those are the file lines. So again, everything is drag and drop, right? So I did it beforehand. So let's say, for example, I want the project on the first line, so I can all you have to do is find that project and just drag and drop it over there. If any of the properties that you selected over here, for example, let's say this manager is coming from my other project, okay? That manager was one of the client was using manager for his job ID, for example, right? But I don't have the manager on this over here. So if I don't change it, so just anytime that I convert that specific field will come as an NA, no data there, right? So you know what? I'm just going to be doing that. I'm just going to overlapping that with part number again. So I don't want to bring that as an empty, for example, right? I'm just going to grab part number, for example, on that same line there, right? So what's going to happen? The software will be putting in the project info over there, part number, description, and again, part number here. The reason why we kept it on the part number, some of the software is actually, on the CNC softwares, right? The software that you use with your machine, they will be picking that line 4 as your marking content, your mark number or whatever, right? So I'll just put it as, and they prefer to have it as a part number, right? So I put it on line 4 as well. And as I said, those are depending on your needs and depending on your machine, right? And the line 5 is the material grade normally, right? So if it's if your machine really needs that info, you can go ahead and include that one, right? And last but not the least, I mentioned on my checklist is the shape size is so important, right? So if I just go to my iProperties again quickly, if I just take a look here, my shape size is actually on the stock number, right? So I'm just going to go back to my properties again, and I'm going to look for my stock number here on that list, so I can just highlight any content here, and I can keep pressing S on my keyboard until I get stock number on this list. So I got the stock number, and I just drag and drop it there, right? So these are the minimum thing, as I said. These are optionals. This is a must and minimal requirement for a quick automation. Over here, I'm just talking about the part stamping. So remember that I mentioned that we can also grab your part number and put it on a default stamping as well. So what I'll do, I'll just do that as well to show you the capacity of the software as well. So as you see on this model, my embossing feature is actually on the web, right? But I'm going to put it on the top line just to show you that I have another SI block will coming in depending on my settings, right? So I'm going to say create stamp. I'm going to put it on the top flange. I'm going to say, put that text height would be 2 inches. And from the top left corner on my, let's say, for example, this is my flange, this border there, right? So I want from that corner, I want to go for, let's say, for example, 4 inches, for example. I'm just giving some, not 4, maybe 5 inches, for example, right? And then in Y direction, I'll go 2 inches, right? So just to give it a reference point where that you want to see that text is, right? I know this is not an imperial, there's not a metric value. I'm just going to turn it off, right? So this is about stamping. So I'm going to go back to the processing again. So remember that I said, like, we're going to be sticking to the XY in order to batch process everything. So I'm going to go back to my settings for XY, okay? And this is, again, the orientation of my profile planes, right? Now, I mentioned that the software is capable of reading the countersink hole, tapped hole. So if we have something like this on the model, what you have to do the software have to have those features, right? So this is one of the examples that I have on this model is like, I do have countersink hole on this here, as you see, right? Countersunk. And at the same time, if I just try to show that, I have a threaded hole or tapped hole. I even have counter bore here as well, something. Yep, there you go, counter bore, right? So if we want to bring them on our NC file, we really have to make sure we have to turn it on. So one of the questions would be like, what if I want to keep that turned on all the time? So we recommend that only use it for special purposes, because the actual algorithm to detect a valid drill is not on feature, because we do not read feature for detecting a drill. Only time that we'll be reading a feature is for special cases. Okay, so let's say if you're importing a step file, for example, right? That step file will not have feature at all, right? So we're going to be reading faces, right? And depending on those reads, we'll figure out like what's the drill, where the drill is, and the feature of the drills, right? I mean, feature means like, it's going to be a through hole all the time for those cases. But as I said, for special cases like, countersunk, counterbore, threaded hole, and those kind of stuff, only time we'll be reading those. Okay. So on this example, we are also reading marking. So I'm going to turn it on. Embossing feature, we're going to be reading embossing feature. I can turn it on, and we're going to be reading bending for feature because I want to show you some sheet metals functionalities. So I'm going to be turning on anyway this one here, and the bevels. So I'm going to show you an example. Like, if you just see that over here, you have a miter right on this part, right? In some machines, even though if you have the miter angles on the DSTV files, as you know, the DSTV has the miter details, right? So some of the machines will grab the details from the NC file and will do the operations through, and including the bevels, because you have for that miter on the web, you have bevels on top and bottom flanges, right? So if you want to bring those ones on your DSTV, right? Because some of the machines additionally wants that, and not only this, like, not only this, that you want to do that for those miters, you also want to do that for the cases like those. So let's say, for example, I want to apply a chamfer over here on this corner, right? So let's say I go to the tools, sorry, not the tools, I guess, over here, go to the chamfer, I come over here, and I'm just going to say like, 0.25, for example, right? So I just added a chamfer or bevel, whatever you want to call it. I want to read that data as well. So if you want to read that data, then you have to turn on your settings for the bevels, right? The reason why we had to use that one, because some of the machine cannot read bevel details at all. They will be stopped. The machine will stop. So for those cases, you're going to be using only the operations that you need. If you don't need it, you don't need it, right? You just you don't need means like, you don't want to include that on your NC file, right? So we covered that part, stamping over there. So and the DSTV is like, pretty straightforward. Like, in some machine have some specific needs in terms of referencing and in terms of profile faces as well, the profile code. So we can always play with those ones depending on the needs, right? Including the text encoding. Some of the machines will run with EFT8 to run the text on their side. So we'll be sticking to ASCII values for now. So there you go. So this is the entire settings that you have to do, and this is one-time settings. And then, the software will be working on it. So as you saw on this model, all I did is, I just made sure that my eye properties has been mapped correctly on my settings here. So as I said, like, the rest of the stuff is like, one-time thing. All you have to care is like, you have to make sure that you're on the stock number, and that's it. And you make sure that, you're on the XY plane, right? So if this is the case, you open your part, you hit on your, by the way, I forget to mention that, like, you can also define where is your working directory. So this is the working directory that I'm working with. So if I just go to that folder there right now, so I see that that folder is empty, right? So I'm going to be creating all my NC1 file on that folder, right? So I'm going to click on save and exit and hit on part DSTV. And then within seconds, I have my entire assembly file over here, as you see here, right? So if you just pull up this settings again one more time, I just want to map it quickly for this mapping. So I didn't have any project details, so that's why it's NA. My part number was test BIM 1. Both test BIM 1, my materials was mild steel, and my description is trial BIM for BIM line test. So as you saw, like, this the mapping is, right? So one of the things that I mentioned, like, that our software will be also grabbing your miter angle. So as you know, like, we have a 45-degree miter over here, right? And this miter, so this is the 45-degree angle. So as I said, some of the machine cannot read that angles from here. In order to add bevels, you still need the bevel details. So those bevel details are part of the AK that's been added here as well. Additionally, the software also added on the top flange, we had 2 bevels. The reason why we had 2 bevels on this side, and the other one was from there, right? So you know what? Let me just show you those on the target folder. See that? So that's the NC1 file we just created. If you just take a look on the timestamp, it's 2:30 p.m. on my 2:31. So it's exactly just we created right now, right? So if you just open it, double click it, as I said, everything is with Notepad, right? You can open with Notepad and see that. And let me just open that with my CMS viewer. So CMS viewer is a software that you can go and download from our website. It's a free software that allows you to open an NC file and just kind of visually verify that. And you can also use our dimensioning feature. When you are handling with NC1 file for the first time, you want to verify that, you can use that tool. Okay, so all I do is I come over here and I copy the path where my NC1 file is and I put it on this location there. So just loading all my NC file. Okay, so as you see, that's my 3D view. All right, and if I just turn off my shape lines, it's going to be showing my CNC lines here. So all those red lines are CNC lines. If I just go to the front view here, as you see, that's coming from the embossing feature. That's my marking content, the KO. That's my pop marks that we had, right? And that's the fillet. That we had the cope there, right? And that's the bevel, right? We had a tiny bevel there. And the bevel descriptions is also been added here as well, which is part of this, right? Part of the AK on the top flange. And if I go to the top flange here, well, by the way, these blocks there, when you are on 3D, the text will pop up like this on our viewer, right? If I just go to the view on the top, then I can see that exactly like what I have here, right? So I had bevels on the start of the bevel on the flange, and at the end of the flange as well, right? And those are the two are, as you see, like our viewer is a wireframe viewer, so we will not be able to show you those countersink or counterbore ones with a solid body, right? And there's a bunch of free viewer that you can download from internet. One of those is Still Projects CAD viewer that I use to visualize some of the time for my clients to visualize in solids, right? So I'm just going to use that tool quickly just for this time, just to show you that we are doing the right thing here. I'm just going to zoom in on those specific drills there just to show you what's happening on those faces, right? So let's just zoom in there and kind of zoom in there just to show you the countersink one. And there you go. See that? Those are the drills. That's countersink one. But our NC1 file is correct. Our viewer is showing, our CMS viewer is showing as a wireframe. So that's why you don't see it. But it's there. At the same time, if I just zoom in there here, see that this is the thread hole that you have over there as well, right? So if I just go to the top as well, so that's the test location that we had, right? And that's coming from if I just come to the other side, for example, I'm just going slow here. If I just go to the top here, this is where my text positioning is, right? For the stamping, that's embossing. But honestly, embossing is not a popular choice. But I just wanted to show you that, we have the capacity. Your best bet would be doing the stamping from your default stamping, right? That's the best. I can just grab your part number and put it on a default location and you're good to go, right? Okay, so that's the part level. So now just want to show you an example. We're going to be doing some examples here right now with the assemblies, right? So let's just move in. Okay, so I'm just going to go ahead and just trying to figure out which one would be my best thing to do. So let me just show you this one here. Okay, so that's a big assembly right there. So I'm just I pulled up already some of the samples here. So we're going to be working on this one here. So this is a sub assembly steel framing platform from my entire assembly there. So I just pulled it up just to show you, like, that I'll be working on this one and create NC1 file. By the way, like, our software will be working on sheet only on profiles, not the round bars, right? So if you have any round bars like those ones, so our software will be ignoring that for now. But if you have the pipes, we work on the pipe. Our pipe works is still in progress, so we are working on it. We are adding features on this, but as of now, we will be able to create NC file only for the straight pipes, okay, without any operations, right? So the cuts, the start cut and end cut will be there with we can give you like this, but not any other additional features. But anyway, let me just go to my bill of materials over here and just to see all the parts there, right? So I see that my shape, I have all my part number right there, and I see that my stock, all my info for the sizes are actually on my text, on my description, right? So all I have to do is, before I do anything, I have to just pull up one part, okay? I'm just gonna still, it's a sub-assembly here, as you see. I'm just gonna go to the part level again, and I'm gonna go to the settings. The reason why I'm doing all this is because make sure I have to do my shape size settings correctly, right? And you have only access to that list when you are on the part level, right? So I'm going to grab this descriptions over descriptions from here. So I'm just looking for descriptions. Here you go. I'm going to dump this over here, 7 exit, and I'm going to go back to my assembly here right now. So all I can do is I can come over here and I can just say, give me the DST for the entire assembly. The software will be running all those parts, or like, and give me an NC file, all those listed files, right? So, or I can just go and hover over, I can just highlight every members and I can just say DST for the selected items even. So once I do that, as you see right now, the selected items was 114, as you see, and it's just creating all those, reading all those members and creating all those NC file for me, including plates. One of the things that I forgot to mention is how you want to how the software will be creating plates, how the software want to see that the plates being placed on your model. So if you're working with plates, the only requirements that we want to see on the plates is either you place it with length and width on this XY, or width length, it doesn't matter, right? So that's that's length and width. But if you are placing your plate like this, okay, on its thickness, for example, right? And that's at this direction is your length, okay? So this is the case that what we will be treating for flat bar. So this how we will differentiate between your plates. So those two are plates, both are plates, but this one over here is a flat bar, okay? So again, anything that you want to bring you as a plate, just make sure you place them like this too on the XY plane, right? For the flat bar, additionally, that all we need is the shape size info, because flat bar is a shape, right? So it have to be mapped to the library. So you have to have the shape size info as well. So going back to my library there, I'm sorry, my all those NC files that have been created in one single shot, as you saw, like it processed almost 112 members and it just created a folder exactly the same name as my sub-assembly. And if I just go in there, I see that I have 52 items, so it's actually 51. One of the things is the conversion report. So it actually gives you the conversion report. So if anything was not being created correctly, I have bunch of warnings, so that can be ignored. Possible error that could be ignored as well. So only thing that I will take care of is if it says that it was skipping a part. So it will just say skip. So I'm just going to Control F and just say look for the word skip. So there was nothing it didn't skip any part. So it's going to say unable to determine the part size and skip that part. Okay, because the software has access to the part number anyway, right? So it will be able to tell you that part was skipped because it was not able to determine the part type. So because the size was not there. So that's the only time that happens this way. Okay, so but if the orientation is not right, So we will not, the software will not give you a warning during the conversion process. The only time that it will be figured out the orientation was wrong when we try and see those NC file on our viewer. So I'm just going to pop everything over here. I'm going to put it over there right now. So as you see here, well, by the way, those are the plates. As you see, like, this is a viewer problem. Again, just to boost your confidence that that's a viewer problem. This is a free tool and we don't invest much on this, but I'm just going to show you on a third-party viewer that's on those all those plates there. So as you see here, this is a plate. Well, our default positioning for the sides was not for the what I meant by that is default stamping. So our default stamping was not great because the plates are smaller, right? So it's going out of the boundary, right? So if you don't want to do that, you can just turn it off and rerun it, right? So anyway, I'm just going to go back one by one and take a look on the plates. So as you see, the plates were all captured correctly. Just the stamping is out of the boundary because of the default value that we have. So as you see, all those plates was captured correctly with one single shot, right? I'm just going to one by one as you see here. Right, and then these are all a bunch of plates, and if I just scroll down, I can see that's my even WT T profiles there. The TBMs there been captured correctly, and if I just even go to other ones, those are all WT here, right? So as you see, very straightforward, honestly. So I'm just going to go to a different one that I can. Let me just take a look at one over here. The reason why I'm just showing you this, there's a purpose for that. Okay, just to show you this, the software can be worked on a custom library as well. The reason why I meant by that is, like, let's say, if I just pull up one of those members from here and take a look on this eye properties of this one there. Take a look here. So this is how this size has been described over here, and this is from one of my Asian clients, and they're actually using GIS library, so which is a Japanese standard, right? So we can always add any new members to our library. So I'm just going to go back to that folder location for the library, right? So if I just double click on this. Which I did, beforehand I added some members already. So those are GIS members that we didn't have initially, right? So, as you see, even they had a different way of naming them, right? So all I did, I come to the CSV file and I just edited those beforehand just to match the naming convention that they have. So the purpose of showing you that is if you have a different way of naming your parts, your shape sizes, you can always come over here and you can update them manually if you like, and the software will be working just fine from there. Okay, so I'm just gonna close this one and just gonna go back to this assembly right there. Okay, so let's say, for example, if I just try to create an NC file for the entire one. So as you see right now, so it's working on 1500 parts right now. Okay, and depending on my settings for the part number, it will just only giving me the NC file with the unique part number. And at the same time, as I said before, if I have, I'm going to show you that when the process is done, we do have access to the bill of materials, and that the bill of materials also includes your quantity as well, right? So, and then the software is actually grabbing those details from there as well. Okay, so let's just bear over there. Almost there. So, as you see, even when you have about 1500 profiles, you're running them all together, right? It will take you about a minute or two, right? So as you see, the process is so fast and it's really, really efficient. Almost there. Just a few seconds to go. And there we are. Okay, so now, as you see, I have again 51 members on this one because these are the 51 unique members that I had. unless that we had some other issues during the conversion process that we didn't have access to the part numbers, for example, right? So let's say, for example, if I just look in the parts here, right? If I just take a look on B01, HB01, and I'm trying to see the quantity would be 12, and my HB02 would be 36, for example. Let's say, for example, if I just go to this models there right now, and HB01, if I take a look over there, and well, this is a size, we're going to show you that exactly, like, this is an unsupported character, that's why it's just coming like that anyway. But as you see here, that's the quantity has been 12 there, right? So the software has the capacity to actually, capture that right there from there. So if you just take a look here, 36, right? So those are the angles, right? So, just to visually verify them quickly, so I'm just going to go Control C and go to my my viewer again and put it on Control F, Control V. Sorry about that. So there you go. So that's my HB1, HB2. So just quickly going through my. So that's an angle. That's an BIM there. So just direct BIMs. No operations been added here because we didn't have anything here. I guess there you go. There's other ones. Some BIMs with options there. So those are the plates again, right? So that's pretty much it, honestly. Like, anything that you want to create over there, just make sure that you have all those three checks. Again, the three checks are like, making sure that your orientation is right, and then you have your part sizes there and the part number, and then from there the software will just run quickly and create your NC1 file right there, right? But let me just go back to that folder again and just take a look on my report. Just to show you that, like, if you have anything part being skipped, as I said, like, unable to determine the part type. So M2080, this one there, as something is not supported, those ones there. So, right. So let's say if I just try to open that, this is an unsupported, as you see, this there's nothing, right? There's no part associated to that or something like, which is not supported by, if I just go to the iProperties here, I can just easily figure out that. And description is something like, this is not, I believe this is not a profile at all, right? But anyway, so just to make sure that's like, the software will give you, like, if anything is skipped, the software will give you a clue which one was skipping, right? And these are like, most of the time your nuts and bolts. If you have nuts and bolts on the model, they'll be skipped definitely because they don't have the size been associated to them, right? So honestly, that pretty much it. I just wanted to show you both on. I grabbed one. We did one example on an imperial shapes, right? And we did this one as in a metric shape. So that's just to show you that, like, we cover both imperial and metric. But again, as I said, like, you can have your custom library, and we can easily incorporate that on our CSV files, and from there, it's just a few clicks to create NC1 files from your assemblies. Before I let you go, I just want to show you one last thing that we have on an assembly that is called tagged item process. So if I just go to the properties of this one here, let's say, for example, like, you have, like, different kind of profiles, but you want to actually process only some tagged items. So if you can give me a custom property, which is DSTV_tag, and if you set the value to yes, and from there, like, let's say you have a big assembly and you just want to process the members that your machine or your supplier can process, right? So I can just click on, and I can come here, I can just say, what, give me the DST for the tagged items, and software will only highlight those members which are tagged already, okay? And I can just say yes, and the software will create NC file right there. But as you see, there is no NC file, and let's just take a look here. All the reason why it failed is because my part size was not there, and I can just easily fix it. What the reason is, because for this assembly, if I just go there and properties, and I can easily see that my size info was in a stock number, right? But on my CMS settings, if I go there, on my proper link is set to description. So that's why it failed all of those, right? So this is the easy way to demonstrate is, like, if you want to do something, if anything fails, the software will let you know, right? So I'm just going to go there again quickly, click on my property link, and I'm going to grab my stock number quickly again and bring it over here. and save and exit, and go back over there and run it one more time. Just want to make sure that my settings was saved. Yep. And run that tagged items again one more time, and I'm going to see this time my NC1 file. So as you see, it's processing 38 members right now, and it will give me the NC file as needed. So just taking a few seconds here, so it should be done. It's just going to be less than a minute, I believe. And there you go, and voila, there you go. See that? So it did give me 29 files right now. If I just go to the report, so as I said, some of the warnings, those are the warnings I can always ignore, but there's no list that any of the part was skipped, right? So all I do, I copy that path over there quickly, and I come to my viewer, put it over there, and just go and visualize one by one. Remember that I turned off my stamping feature, right? So that's why none of my parts contains stamping right now. So there you go, copes and drills, being captured, pretty straightforward. As you see, very straightforward, honestly. It's very straightforward. All you just make sure that's your when you are working on an assembly. Let's say come back over here, bill of materials again. You just make sure that you have your unique part number, you have your sizes there, and you make sure that you're following our call-eye approach. And from there, you're good to go, and just single-click solution in order to process your assemblies from Inventor model and send it to your CNC machines. And thank you very much for your time, and hope to see you in one-to-one session when you want to know more about our software. Thank you.